Capacitor and capacitance. Capacitor is a device used to store electric charge. A device used to store electric charge is said to be capacitor. But capacitance is the ability of the capacitor to store electric charge. Capacitance is ability of the capacitor to store electric charge, whereas capacitor is a device used to store electric charge. This is a circuit. Here, capacitors are arranged in parallel in circuit. Capacitor, capacitor. Two plates which are arranged in parallel, just like this. Between the two plates, there is a separation. There is a separation, a distance between the two plates. Here, there is a battery or a source which is connected to the capacitor. At this time, this is the positive terminal of the battery and this is the negative terminal of the battery. At this time, the capacitor begins to store electric charge because it is a device used to store electric charge. Two plates are arranged in parallel, which is found at certain distance. If these two plates are in contact, the two plates, if one plate store positively charged particles, the other plate store negatively charged particles. But the two plates store different sign of charge, but they carry equal magnitude of charge. For example, if the magnitude of the charge carried by the first plate is Q, the magnitude of the charge carried by the second plate is minus Q. Equal in magnitude but opposite in sign. If the two plates are in contact, the net charge on these two plates is equal to 0. This means Q minus Q, which is equal to 0. Because of this, there is no stored charge on the capacitor if there is no separation between the two plates. Now, this is a circuit. In the circuit, this is parallel lines is the circuit symbol of the capacitor. Plates, there are plates here. If it is given in the circuit, this is simply a line, parallel line, which represents the circuit symbol for a capacitor. Charges are stored. This is positive charge, this is negative charge. There is a separation between the two. Circuit symbol for a capacitor. Simply it is a line. This is a circuit, this is two lines, parallel line. This is a battery. One positive terminal is large and the negative terminal is small. Now they are arranged just like this. This circuit is expressed in this way. Now, factors affecting the capacitance of the capacitor. Factors affecting capacitance means the ability of the plates may be affected due to certain factors. The first factor is one dielectric materials. Dielectric materials. Dielectric material is an insulator, an insulating materials which is inserted between the two plates. This can affect the capacitance of the capacitor. The ability of the capacitor can be affected by dielectric material. Dielectric material is insulator, which is inserted between the parallel plate capacitor. If these two are parallel plate capacitors, dielectric materials may be just like inserted between the two plates. Where these dielectric materials are is inserted between these plates. Electrons cannot be escaped from this plate to the second plate, from negative plate to positive plate. Impossible to escape for the electrons from the negatively charged plate to the positive towards the positively charged plate. Because of this, inserting dielectric materials between the two plates can increase the capacitance of the capacitor. The second factor is area of the plate. Area of the plates. The area of the plate is also another factor that affects the capacitance of the capacitor. If the area of the plate increases, the capacitance of the capacitor can be decreased. This means capacitance is directly proportional to area. Capacitance is directly proportional to area. This means when the area of the plate increases, capacitance of the capacitor is also increases, and vice versa. For example, consider these two circuits. Circuit 1, the plates, the capacitors are which are arranged in parallel, just like this. Here, the same battery. Let's say this is 10 volt. Now, another circuit, small plates, just like this. This is 10 volt. Now, at the same voltage, the charge stored on this capacitor is different from the charge stored on this capacitor. The magnitude of the charge stored on this capacitor is different from this circuit. Here, maybe this circuit. But the voltage delivered to the circuit for two of the circuits is the same, 10 volt, 10 volt. The charge stored on this plate is different from the charge stored on this plate, because the area of the plate is, this plate is very small when it is compared with this. Because of this large magnitude of charge is stored on the first plates, the first circuit, that means. Therefore, capacitance is directly proportional to the area of the plate. The last one, the separation between the two plates. The third point, separation. Distance or separation between the plates. Capacitance is inversely proportional to the distance between the two plates. For example, if this is plate 1 and another plate here, plate 2, this is the distance between them. Here battery connected to the circuit. Now, capacitance is inversely proportional to the separation between the two plates. When the distance between the two plates is increased, the ability of the capacitor will be decreased. Therefore, from these two mathematical expressions, if there is no dielectric materials between the two plates, capacitance of the capacitor is equals to permittivity of free space times area of the plate over the distance between the two plates. If no dielectric between the plates, if there is no dielectric materials between the two plates, Capacitance of the capacitor is equal to permittivity of free space times the area of the plate over distance between the two plates. And if there is dielectric materials between the two plates, capacitance is equal to relative permittivity of the dielectric materials times permittivity of free space times area over D. If there is dielectric materials, materials between the plates. Because of this, when dielectric material is inserted between the plates, the capacitance of the capacitor is increased by the factor ER, increased by the factor which is equal to the relative permittivity of the dielectric materials. This is valid only when there is no dielectric material. This expression is used when dielectric material is inserted between the plates.